Okay, in this video we will just be looking at how to find the Laplace transform of a simple function using the definition of a Laplace transform. So this is the definition. Laplace transform of some function of t is equal to the integral from 0 to infinity of that original function times e to the negative st. Okay, so let's see what happens with this simple function just called t. So Laplace transform of t would be equal to the integral from 0 to infinity of the original function, which in this case is just t, times e to the negative st. And now to integrate here, we've got two expressions involving the term t that we're looking at. So we're going to have to do some integration by parts. Integration by parts. Yes, what does this say? Remember the rule from earlier calculus is that the integral of u dv is equal to uv minus the integral of v du. Yes, we have to decide which of these two expressions here are going to be called u and which one's going to be called dv. In this case, we'll choose u to be equal to t, and we'll choose dv, the other part here, to be the rest of it, which is e to the negative st dt. Now if we have u, we need to find du as well. The derivative of t is just 1 dt. And now to find v, we'll have to find the integral of this expression. And if you integrate that, I'm not going to do all the integration here, but you'll see that it's equal to negative 1 over se to the power st. Okay, so now we have all these parts here, so we can just go on from this line here. So now we'll see that the Laplace transform of t is equal to, so we had that this whole expression here was this big thing here. So now we're going to rewrite it as uv, which is u times v, so that'll just be equal to negative t over se to the st. Negative t over se to the st. And we have minus the integral, we're still working from 0 to infinity, of v du. So that'll be v du. V is negative 1 over se to the st, and du is just dt. Okay, so we can go ahead and just rewrite this part as it is, negative t over se to the st. Now we need to integrate this part here. So what I'm going to do is I'm going to go ahead and factor out the negative, this part here, the negative 1 over s. So if we factor that out, it becomes plus 1 over s integral from 0 to infinity of e to the negative st again. Now we've already calculated the integral of this part here. As you can see, the integral of e to the negative st was that v expression there. So that'll just be the same in this case again. Let's go ahead and rewrite negative t over se to the st plus, okay, we're gonna, let's just say plus 1 over s, and if you integrate this expression here, it becomes that one, so we'll just rewrite that, negative 1 over se to the st. And we have to integrate this whole thing from 0 to infinity, so we have to evaluate it from plugging infinity in here to plugging 0 in there. I'm just going to rewrite this as one term, make it a bit easier. So you see the denominators in this case are almost the same. They're not. In this case it's s squared e to the st, so we need to multiply this whole expression by s over s to get that to an s squared denominator as well. Okay, so the new denominator will be s squared e to the st. Left hand side will be, we needed to multiply with an s here to get the s squared, so the top has to be multiplied with an s as well. So we've got negative st, and 1 times negative 1 gives us negative 1. Okay, and that has to be evaluated from 0 to infinity. Now, what will happen if we plug infinity in there? So we'll have to say negative s times infinity minus 1 over s squared times e to the s times infinity minus negative s times 0 minus 1 over s squared e to the s times 0. Okay, now this part is a bit interesting, because we need to see here, we know we can't really work with infinity, easily at least. So this part here, we need to see if the numerator or denominator increases or decreases much quicker than the other one. Now you can use L'Hopital's rule to also check this, but in this case it's fairly easy to see. We can, when working with infinity, we can basically ignore the constants, the negative 1. We can ignore the s squared, that's not going to make much of a difference. So we can basically just look at that part. Infinity versus e to the power of infinity. Now let's just see which one increases faster. If we go 1 over e to the 1, that's some fraction. If we go 100 over e to the 100, that's much smaller. We go 1,000,000 over e to the 1,000,000, that's already becoming very close to 0. So if we tend this to infinity, this whole expression will become something over something infinitely larger, so that'll tend to 0. And if we then subtract s times 0, that'll just be 0, so we'll have negative 1. And e to the power s times 0, so e to the power 0, that'll be 1, times s squared is s squared. And now 0 minus negative 1 over s squared, that'll just be equal to 1 over s squared. And that's your Laplace transform of the function t, by using the basic definition of a Laplace transform.